Welcome back to the FFISAcademy. I'm your host JD, and today we're going to explore forces and Newton's laws of motion. So let's get things started. Whenever someone brings up Newton, everyone's first thought always seems to be the classic phrase, every action has an opposite and equal reaction, which refers to Newton's third law of motion. But let's rewind things a little bit and start with the first law. Newton's first law states that a body will continue in its state of rest or uniform motion in a straight line unless a net or resultant force acts upon it. But what does this really mean? Take this box as an example. When we have balanced forces of the same magnitude in opposing directions, then the box will stay in its state of rest. However, look at the second scenario, where the forces are unbalanced and the force from the left is greater than the one from the right. In this scenario, the box will accelerate from left to right. This is because forces and acceleration are linked, as the greater the force on an object, the greater its acceleration. Which brings us nicely into Newton's second law of motion, which states that the acceleration of an object is proportional to the resultant force on the object and is inversely proportional to the mass of the object. This resultant force will cause the object to change its velocity, as we know, but how do we calculate the magnitude of this force? Well, quite simply we use F equals ma, where F is the resultant force in newtons, m is the mass of the object in kilograms, and a is the acceleration in meters per second squared. So let's see an example. A truck has a mass of 3 tons and is travelling at 80 kilometers per hour. The driver hits the brakes and the truck comes to a stop in 7 seconds. What is the resultant force? Well, firstly, let's convert to the correct units. So we have velocity, v, is equal to 80 kilometers per hour. Now to convert this into meters per second, we need to take 80, times it by 1,000 to convert from kilometers to meters, then divided by 3,600, which converts hours into seconds. And therefore we get velocity is equal to 22.2 meters per second. Now let's do the same thing for mass. We know there's 1,000 kilograms in 1 ton, and we have 3 tons. So m is equal to 3 times it by 1,000, which gives us 3,000 kilograms. Next, we have to calculate the deceleration over the 7-second period. Now we know that 22.2 meters per second is the velocity, so divide this by 7 seconds gives us a deceleration a, which is equal to 22.2 over 7 is equal to 3.17 meters per second squared. Then, simply using Newton's second law, which again is F equals to ma, we can substitute our values in. So F is equal to 3,000 times it by negative 3.17, which gives us F is equal to minus 9,510 newtons. Note the negative arrow here. This just shows that the resultant force that brings the truck to a stop is in the opposite or opposing direction to the truck's forward motion. And that's how we use Newton's second law to calculate the resultant force, which brings us full circle back to the beginning of this video with Newton's third law of motion. Now, actually, the true definition is whenever two objects interact, the forces they exert on each other are equal and opposite. And an easy way to visualize this is to think of a rocket, as poorly drawn in this example. When the engines ignite, they exert a force on the exhaust gases, forcing them down towards the launch pad. And what helps propel the rocket upwards is the force the gases exert back on the engines, hence creating lift. The rocket then simply takes off, and in a nutshell there you have it. Newton's 3 laws of motion in basic terms. If you loved the video, please give it a like and remember to subscribe to the FFISAcademy for more simple scientific content. See you next time.